Language is a particularly remarkable tool that changes the lens by which the mind sees. And when you swap language, you swap the lens by which you see everything. The map is not the territory, and language is not reality, but it's a model of reality. And the language that you use terraforms reality. So the map is not the territory, but the map terraforms the territory and creates this incredible cyclic loop by which we see the world. And I think it's the idea that if you can swap language, you swap the lens by which your mind sees the world, which gets to the heart of something that I've found true in my own life, but I think we all experience this. And that is that shifts in perspective can change everything. It's that nothing has changed, and yet everything is different. And this particular story around translating animal communication, discovering animal language, started, at least for me, in 2013. The history of this goes back centuries, but for me, it started in 2013 when I heard an NPR piece about these incredible monkeys, gelato monkeys in the Ethiopian highlands. And they're known to have one of the largest vocabularies of any primate. The researchers that work with them swear that the monkeys are talking about them behind their backs. The problem is there just wasn't enough data to be able to translate. And the thought was like, okay, but if we could go out and put microphones in the field, a huge microphone array, capture an entire species at once, and make a sort of a digital footprint, could we translate their language? And in 2013, the answer was no. Because in order to translate a language, you have to have examples of translation. But with animals, you don't have that. And so every year, would return. 2013, was it possible? No. 2014, was it possible? No. 2015, no. But something remarkable changed in 2017. In 2017, back to back, October 30th and October 31st, two different papers independently discovered different techniques to do the same thing. And that was to translate languages without any examples of how to translate, without any key, without any Rosetta Stone. And the process is actually remarkably simple. It was also in 2013 that researchers discovered that you could build a shape that represents language. Think of it as sort of a galaxy where every star is a word. And actually, right behind me here, you can't see it super well, but this is actually the shape of English, the top 10,000 most spoken words. And in high resolution, you can really see the points move around. What's interesting about this shape is that points that mean similar things are placed near each other. So fast and faster are sort of near each other. Dog and cat are somewhat near each other, but cat and lion are even closer together. And what's cool about this shape is that it's not just words that mean similar things are near each other. It's that the relationship between concepts, between words, is represented geometrically, which is to say, king is to man as woman is to queen, as an analogy. So analogies have geometric form. So king is the same distance and direction to man as woman is to queen. And so you can actually just do king minus man is this distance and direction. You add it to queen, and that just, or woman, and that just equals woman. There's a direction in here for what I call pretentiousness. And that's just book is to tome as, say, smelly is to malodorous. And so you can just do book minus tome, that's pretentiousness direction. You add it to smelly and it equals malodorous. It's a really beautiful and sort of amazing thing. And it all stems from actually a 1958 realization from J.R. Firth, who's a British linguist, and he said, "You shall know a word by the company that it keeps." And that's how these models are built up. They're essentially looking at the context of every word. The computer doesn't understand the word, but it understands the words that are near it, and from that out pops the shape. Okay, so we have the shape for Japanese. We have the shape for German. We have the shape for English. What do you do then? And here is the really, really surprising thing. It couldn't just be the case that you could take English and rotate it on top of Chinese and that they would fit, because the cultures are different, the context is different, the history is different, we see the world in different ways. And yet, when researchers tried it, the two shapes lined up. Not perfectly, words mean slightly different things, but the relationships between things are similar enough that the shapes match up, and the point which is dog in English overlaps with the point which is dog in Chinese. And that doesn't work for just English and Chinese, but for Japanese and for Esperanto and for Finnish and for Turkish. Almost all human languages seem to share a kind of universal shape. And I just think that is incredibly profound and deeply surprising. It's not something I think any one of us would have expected before we tried it out. Because when we look at each other, we see our differences in contexts and histories. And what deep learning is teaching us in a way is to see the similarities underlying us all. What's interesting is you can go even further. There's a recent study where they put people into fMRIs, brain scanners. They had them look at objects, they knew what the objects were, and then they would scan their visual cortex. And they learned a mapping. That is to say, from the scan, they could predict, they could reconstruct what the person was seeing. And that already is sort of surprising because we're able to look inside someone's mind and extract what they're seeing. But what's even weirder is that the mapping that worked for me would work for you, would work for someone else. There's something universal about this mapping. And what's really intriguing is, and no one's tried this yet, can we map language into the space, which is what we see in our brains? Is there a correspondence? We don't know, but it's very, very intriguing. All right, so one way of thinking about why this works is this. Language is sort of like a style, right? Like imagine French is like pointillism, and maybe, I know, German is like brutalism. Hopefully I won't get in trouble for any of these things. The way the types of strokes of the paintbrush, the colors they use, very different. And yet when you step back and you look at the pictures in pointillism and brutalism, you can sort of see the similarities because both paintings are mapping sort of, they keep consistent the internal relationships of the world that they're painting. And what deep learning is learning how to do, and what these shaped rotations are learning how to do, is to translate between the styles, keeping the relationships inside of every worldview the same. And this really gets to the heart of another of my favorite parts of language, which is metaphor. What is a metaphor? It's a hard thing to think through. But I think a metaphor is actually very simple. It is just a map that preserves relationships. Right? It lets you understand something you can't see with something that you can by mapping the relationships in the thing you can see to the thing that you can't. And once you understand metaphors in this way, a lot opens up, or at least for me. An example is math, geometry. Klein, a famous geometer and also progenitor of quantum theory, he described geometry as the mapping of space to itself that preserves angles. That's it. That's all of geometry. It's a metaphor of space to itself. What is translation? Translation is a map that preserves connotations, right? It's a map that preserves analogies. And that gets to one of the most beautiful sort of summarization of all of my favorite terms, which is that translation is a metaphor that preserves analogies. I just think that's so cool. And we can finally understand when we rotate one language onto another to translate between the two, that is a computational metaphor. So we've sort of gone way out. We'll come back in. Why are we so excited about the ability to translate between languages without a key, without a Rosetta Stone? It's because for the first time we can start to ask, well, if we can build the shape for human language, we can definitely build the shape for animal communication. And then the question becomes, what shape is it? Does it fit anywhere in the universal human meaning shape? Maybe. Or does it actually match better to human emotions and the facial gestures that people make? Or maybe it maps better to human music, Or maybe it looks more like images or 3D models. We don't know, but we're on the cusp of finding out. So in the end, I think that these kinds of tools are going to be the telescope times the microscope of our era, because they let us see at greater granularity we've ever seen before, and also with greater scope than we've ever seen before. And the telescope, right, it fundamentally shifted human perspective and human identity. It let us look out at the patterns of the universe, and what it taught us is that Earth was not at the center. I think these tools are the telescope of our era, but they're going to be a kind of internal looking. They're going to let us look at the patterns of the universe, and what we're going to discover is that humanity is not at the center of the universe. And that kind of humility and interdependence is what I think we all need to be able to survive. Thank you.
Aza, how wonderful. Thank you so much. That's such a stimulating, wild ride of a talk and concepts. And, you know, I'm so moved by the scale of your ambition, but also the idea that, you know, what we can get so bogged down in feeling, in identifying difference actually on a geographical sort of map is the same. So good luck with, tell us anyway, what's the time horizon for decoding animal language? Is there one?
I mean, really hard to say. We're walking off fundamentally into the unknown. We think, you know, we're already making substantial progress now. So I'm hesitant to give like a timeline. But one of the things I'm most excited about is that we're building this library, the Earth Species Library. And it just starts to collect many, many, many different of the cultures and behaviors, communications of the species of Earth. And the reason why I think this is so cool is that science is really fundamentally a comparative kind of game. And this lets us look at the shape of, say, sperm whale to understand humpback whale, to understand dolphin, to understand orca, to understand bat, to understand. And so you can start to see how the whole thing starts to create this huge set of contexts with which you compare one to the other. Every language becomes a key to decode the lock of every other language. Everything is a metaphor for everything else. So yeah, I don't know the timeline, but I think much sooner than we expect.
As I love that all the while the English language is swirling behind you.
Yes.
I'll forever keep the image of you as astronomer of language.
Oh, that's beautiful.
Yeah. So yeah, much good luck with the galaxies you're off to discover, and thank you so much for being here with us.
Thank you so much for having me, Trish.
Yeah, please everyone check out Earth Species and all of Aza's other projects. It's quite incredible what he's been doing.
Thank you, Aza. Thank you.